Have you ever had to image a RAID array or had to reassemble a RAID out of individually imaged drives? In this video, we will be looking at imaging and reassembly of RAID volumes with Linux. Please help me out by hitting the subscribe button and prove your love. In the forensics world, I have been tasked to image RAID arrays many times. And there's several options on how to go about doing this, right? You can shut down the RAID and then image each component drive separately and then put it all back together later. And this could be a big issue if the storage system is using a hardware RAID controller and you don't have that same RAID controller back at your lab. So a better way is to image the operating array so a reassembly of the individual hard drives at the examination time can be avoided. And one of the ways to do this is basically to boot the RAID server with a bootable operating system like Kane so that we can control the file system. So in this example, the first thing I'm going to do is find the array in the system. And I can run lsblock to see what's connected. And in my case, I see that I have 4 drives, SDB, SDC, SDD, and SDE. And we can also see that the system has already associated some of these devices to a RAID, as they have the MD127 and then the RAID 10 specification that's attached to them. We can also use the mdstat command to see what arrays are available. So if we do cat of proc mdstat, in my case, I have a RAID 10 array that is connected to the system. So here we see that the system recognizes the RAID 10 array with all 4 of its components. And if the array is mounted, I would unmount it to make sure that the files are not changing while we're imaging it. And so we can check it with the mount command. In this case, I'm going to do mount /grep MD127 because that's the name of the array that the system put together. We see that the array is not mounted, which is good. Then we can go ahead and image the RAID array just like a regular disk volume. So the command to do is sudo dc3dd if equals /dev md127 and then output to a dd file on an external media that I had already mounted. of equals /mnt/hd/raid-dd. I'm going to do a md5 hash equals md5, and I'm going to output a log equals raid-demo.log. And once it's done, let's take a look at the resulting image file. I'm going to do a ls-lh of /mnt/hd/raid.dd. Note the size of this image file is only 2 gigabytes because that's the size available to the array. In this demo, I have 4 1 gig devices which are configured as a RAID 10 array, which means only half of the space is used as a mirror, and that's why we ended up with only 2 gigabytes of usable space. And the result is an image of a disk that any forensic tool can analyze without needing knowledge of the original RAID. And we can double check that with doing a disk type of /mnt/hd/raid.dd. And here we see that this looks just like a typical individual drive. It's got a partition on it with a file system. And we can also see that it was previously mounted. Now let's take a look at the situation where another forensic examiner had shut down the RAID and then imaged the individual drives. And now you're tasked with the examination. So in this example, we're given 3 E01 sets from a RAID 5 array that had each of the 3 component drives imaged individually. So let's go ahead and cd into mnt/hd RAID 5. I'm going to do a ls-l, and we can see the 3 sets here of RAID 1.e01, e02, e03, e04, RAID 2.e01, 02, 03, and then RAID 3.e01 through e06. So the first thing we're going to do is we're going to create some mount points for each one of the E01 sets that's going to be mounted. We're going to do sudo makedir /mnt/disk and then curly brace 1.3 end curly brace. So this is going to cause the command line to interpret this as, hey, I'm going to start with disk 1 and then fill in for disk 2 and then disk 3. So essentially this is going to create the mount points of disk 1, disk 2, and disk 3. And we can verify that by doing a ls/mnt. And here we see that we have folders called disk 1, disk 2, and disk 3. We want to actually mount those E01 sets to see what's inside. So I'm going to use xmount to do that. So I'm going to do sudo xmount --in ewf raid1.e ? So remember, with xmount you have to give it all of the segments. So I'm going to use the wildcards of !?, to match all of the E01, E02, etc. And then for the output format, I'm just going to do a raw dd, so --out raw. And then lastly, where do I want to mount the E01? I want to put in /mnt/disk1. So it comes back with no feedback. Let's go ahead and up arrow and then do the same thing with RAID 2 and disk 2. And then similarly, gonna up arrow again and do disk 3 with RAID 3. So we've mounted each one of the 3 E01 sets. So let's take a look at the partition tables of the resulting DDs. I'm going to do disk type of /mnt disk1 /raid1.dd. And it comes back and gives us the partition table that has one partition, and it is type of FD, which is Linux RAID. And I'm going to go up arrow and do the same thing with disk 2 and RAID 2. And then I'm also going to do the same thing with disk type of MNT disk 3 raid3.dd. All right, so they're all one partition each, and they're all typed RAID. So the next step is to use kpartx to map each one of the partitions to a loop device. So we're going to do sudo kpartx -av for adding a loop device, and then v for verbose, of /mnt disk1 /raid1.dd. And this one tells us that it's created a loop 1p1. I'm going to go up arrow and do the same thing with disk 2 RAID 2. This one gives me a warning that it has a valid GPT signature but an invalid PMBR. This could be an artifact of me not properly wiping the drives before using them for the RAID. So let's go ahead and ignore it for now. And then I'm going to, again, do the same thing for disk 3 RAID 3. All right, so now we've got each of the partitions prepped. The next thing to do is let's take a look at the RAID status. I'm going to do cat of /proc/mdstat. And this comes back and tells us that, hey, we've assembled a RAID device called MD127. It is now active. It is a RAID 5 comprising of these 3 components. And then it is this size and the chunk size and algorithm and so forth. And it's got 3 out of 3 disks, and they're all being utilized. So what happened here is that after we did kpartx, the system was able to detect the RAID 5 and then automatically assemble it for us. So at this point, the RAID is already ready to go. We can go ahead and mount it. We can go ahead and do sudo mount /dev/md127 and then put it to a mount point. I'm just going to call it /mnt/raid. And I get a warning that the device is write protected and it's mounted at read only. And this is because we're mounting actually the E01 images. So the read only is actually a good thing because we want to protect the evidence. So once it's successfully mounted, we can cd into the mount point, cd/mnt/raid, and we can take a look around. We can do ls-l, and here are the files that were on that original RAID. Let's take a look at the file called secret because it's called secret. We got to look, right? So let's go ahead and do a more of secret.txt. And look at that. Linux is awesome. All right, so now that we've done our exam, we'll have to clean things up by unmounting the RAID and then deactivating the RAID. Let's go ahead and do a cd out of there so we can unmount the mount point, and then semicolon sudo umount of /mnt/raid. And then next thing is we're going to stop the RAID. So sudo mdadm --stop /dev/md127. And it tells us that it stopped. And now we can unwind all the kpartx portions. So sudo kpartx -dv for delete /mnt/disk1/raid1.dd, and we get the feedback that it's deleted the loop1 p1s and the loop ones. And we do the same thing with disk2 raid2, and it's also deleted the loop of loop2. And then we do up arrow again and do disk3 raid3 and confirm that it's deleted the loop 3. And lastly, we have to unwind the xmount portion. So we do sudo umount /mnt/disk curly brace 1.3 end curly brace. So this will go ahead and unmount each one of the 3. Assembling raids can get much more complicated to work with because you need to know the raid level, if it's a raid 0, raid 1, raid 5, raid 10, etc. You need to know the RAID algorithm, as some NAS manufacturers use their own. You need to know how many drives are used in that array, because sometimes there are spare drives in the system. And then sometimes the system may be operating at a degraded level. For example, you only have 3 drives out of 4 for RAID 10. You will need to know the block size used for striping and more. That's why it's easier to image the RAID array as assembled. But with what you've learned in this video here, you should have the basic tools to get you started. For a basic tutorial of raids, see this video here. For more videos on the Linux command line, make sure you watch these videos here. Make sure you click on the blue monkey to subscribe. Thanks for your time and happy hunting.